In this part of the lecture, we'll learn how to find the equation of a line that's parallel to a given line. Let's look at our coordinate axes. We can see there's a line y equals mx plus c. If we put a parallel line on there, the thing in common between these two lines is that they have the same slope or the same gradient. The equation of the second line that I've drawn is going to be of the form y equals mx plus some constant, we'll call that c1. If we put another one up here, again parallel to the other two lines, this is also going to take the form y equals mx plus some constant value, we'll call that c2. The gradient, or the slope, of parallel lines must be identical. And that's the key point that we need to bear in mind when we're solving any problems where we need to find the equation of a line that's parallel to a given line. So we'll look at three different examples. In the first example, we want to find the equation of the line parallel to y equals 2x minus 1 passing through the point 7,5. So this is very easy. All we need to do is write down our equation y equals 2x plus c, and it goes through the point 7,5. All we had to do there was compare the gradients. They're both in the form y equals mx plus c. Y equals mx plus c is certainly the most useful representation for solving these types of problems. So y equals 2x plus c, all we have to do now is plug in those values. So we're going to have 5 equals 2 times 7 plus c. So 5 is equal to 14 plus c, so that implies that c is going to equal minus 9. So our equation is going to be y equals 2x minus 9. In example 2, we want to find the equation of the line that intercepts the y-axis at 0, 2 and is parallel to the line passing through A, 3, 5 and B, 4, 7. So what we have here is a scenario where we know what the intercept is, but we don't know what the gradient is. So our equation obviously is going to be in the form of y equals mx plus 2. This is what we're interested in now, finding the value of m. We know that it's parallel to the line passing through the 2 points A and B. But as we saw previously, if we know any 2 points on a given line, we can find the gradient. And it's really easy to do that, isn't it? The gradient, m, is going to equal y2 minus y1 over x2 minus x1. So let's plug in those values from the two coordinates, and we'll have 7 minus 5 over 4 minus 3, which is going to be 2. So straight away we can write down our equation now. Y is equal to 2x plus 2. This time we want to find the equation of the line parallel to 3x minus 6y plus 2 equals 0, passing through to point 1, 1. Straight away what we need to do is rewrite the equation in the form y equals mx plus c. So we can write that as 6y equals 3x plus 2. Dividing by 6, we'll get y is equal to a half x plus 1/3. So we want to find the line parallel to y equals a half x plus a third that passes through the point 1, 1. So the equation that we're looking for is going to take the form y equals a half x plus c. So if we plug in those values, 1 and 1, we'll get 1 is equal to a half of 1 plus c. So that's going to imply that c equals a half. So therefore, our equation is going to be y is equal to a half of x plus a half. Now have a go at the multiple choice question.